Okay, we can totally do that as well. Get cache components, get physics state. Get physics state I could see as something we could call. Get bounds and get height is also. Those are things that we might want. Get collision physics channel. Yeah, we might want that too. Get cache components? I don't think so. Probably shouldn't be grabbing those. Those should be private. No, those should be public because we're grabbing them on some other things, but I don't think they should be. Shouldn't be blueprint accessible, I don't think. Oops. So it's looking pretty decent. We do want to call a few things. Like, we do want a reset movement data. Basically, we just will re-clone our data, our movement-based data. And then we also want to be able to get our base movement data. Just like get base movement data. Base movement data. Because we'll need our base movement data because we might want to reset like just the velocity or something else, or return our double jump state to what it should be, or whatever small things we need. Alright, let's see if that compiles. Enter back. Yeah, one of the issues with calling stuff from blueprints is everything that's callable by a blueprint has to be a different name. And C++ allows you to name things the same thing, but so we need like another thing with like can jump. It just does something like this. Is the direction even used for can jump? Yeah, it totally is. Yeah, we can do like can jump. Basically, if we do this, it's not going to be recursive for all return points. Because we're using a bunch of overloading of functions, which is basically a function with the same name, but it has different arguments, and it'll kind of figure out where you want it. Yeah, so we can't just do that. So this is the part where I'm like, I don't really like. We're just gonna do can jump blueprint and just do that way. Some of the names is just like, no, I want the can jump function. I don't want to have to call it some other weird thing for some arbitrary reason. So let's see, what do we got after this? We have write the flying object physics. So we need to write the physics that are going to govern how a flying object works. Yeah, endure back. So we'll have to figure out exactly how we want that to work. So that should all be exposed to blueprints, so we can call them. Just double check everything's still working, and because if we're going to move on to the actual flying object physics, then we should make sure to check in our work and do that sort of thing. Good. All right. So make sure to check all this stuff in. But I think I'm going to take a short break right here. We're at the 8-hour mark, so I should probably take a few minutes so I don't just lose all consciousness at some point here and just fall apart mentally, which is already starting to happen, of course, but we're just ignoring that for now. Because we've actually accomplished a pretty good bit of all the things at the moment. We got all of our stuff is now tunable, all of our stuff is data driven. We cleaned up a whole hell of a lot of code. Momentum is implemented in there, and all of that. So, and it's all exposed to blueprints. So we just need to write the flying objects and implement smart spawn, and we should be pretty good. Don't headbutt the keyboard. Yeah, that was what, Scorpion or whatever fell asleep at his desk, or her desk, or its desk. That sounds not super fun. So I'm gonna take maybe 10 minutes or so. We'll see. I think I need to get something to eat. I need to walk around and all that. So I will be back. Sorry. All right, good. I was more worried about the desk than I was about Scorpion, of course. Alright, I think we'll get back to actually doing some work here. So we want to make basically flying objects and smart spawns. We'll start with flying object. So the first thing we're going to do with a flying object is, why don't we just make a flying object, like a movement type, like a flying fat sack. And of course, the ever-present compile. Just gotta do more compiling. So we're looking for update flying loco. Right now it just doesn't do anything. So where exactly do we have the flying locomotion? It's actually part of the movement data. So what we can do is we can just take our fat sack movement data and we can duplicate it. Let's say fat sack flying movement data. And all we have to do is just change him to flying and change him to smart place, or how about let's just, yeah, smart place. So maybe we should actually do the smart placement first. So why don't we just do that to start with. And we're going to need a fat sack proxy to actually use the fat sack flying movement data. So what does our basic place object on the ground do? It just says able to place on floor, update snap to floor's point. Well, for our smart place, what do we want to do? Well, let's check our overlap. Let's just do overlap movement object, this, and I'm going to say f vector position equals get position. And this response, we'll have a response here. Call it collision. So if we actually have a collision, then we'll do some stuff. We're going to need to actually call the static method for that. We collided with our smart place test. So if there was no collision, basically what we're going to do is just return, we're just done. Just going to do info log. We were able to place ourselves properly where we spawned. So we're going to have to check our current state. So our current state should basically be like, are we on the floor or not? Is something that we're going to have to do. So basically we're going to want to do like a calc floor snap. And our DT should be like just our physics step time, maybe. We should kind of switch off of exactly what type we are. Because if we're a different collision type, like we are a flying creature, we shouldn't worry about it. But if our collision type is we want our movement type. So for flying, we're just gonna set like our current state is certain things. So if we are locomotion, yes, on ground. If it's locomotion, we're going to attempt to snap ourselves to the floor based on this thing. Just be like, if we're able to snap ourselves to the floor, otherwise we need to not be stuck to the floor. We're on the floor, we're on the ground. If we're not on it, then we're like in the air. And if we're flying or whatever, I'm just gonna say like, well, you're in the air. Not a problem. And we'll do the same thing for a few other things here. So what are we going to do for overlapping our movement object? Should we have like some sort of rule for placing our object? Because I think basically with our smart place, we could probably get away with something like, if we're trying to place our object and there's too much here, we could kind of just do a grid search, kind of like just move you here, 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 and just move out by basically just keep moving out in a direction until we find a spot for you. So we're just going to, we're going to have a maximum number of tests. So we do need a const. It's going to be a static constant 32 g max smart object place tests. I think that's going to be like, just set it at 100. And we're just going to move out and follow this grid. So it's basically going to be, we're going to have like int32 level, and it's going to be 1, and what's our height? We want to like get our bounds and then get like our object. Yeah, we'll want to get the bounds. So we're like, okay, get the bounds. So fbox bounds equal get bounds. And this thing doesn't have to be too smart, really. This can be really stupid. So we're just gonna do like 4 and 32 I equals 0, I is less than, like, you know, our smart object place test, and just do a plus plus I. And just basically it's we're just basically doing like f vector test position equals position, and we'll just do like test position dot y equals like position dot y minus, and then we'll do like let's just do n32 tests equals 0 for test is equal to that. And we're gonna have like n32 x y, set those to 0 and 0. So it's basically going to be like, we're going to minus on like n32 sx equals 0, and then sy equals like a -1 here. Basically just go we can actually just do it even dumber than all this stuff, because we basically have like an angle. So it's just like float angle, and then it's like float distance from center. Like the angle is 0, the distance from center is going to be like bounds dot we should just like call get height. So we're gonna have like float like distance step. We're just gonna get the height. And all we're going to do is we're going to do like angle plus equals. It's going to be like we can just increase the angle by, it's like 360 divided by like maybe, how many steps do we want to do? Maybe like 16? You could just do 10, so it'd just be like, yeah, so if angle is greater than like 360, then we just say angle minus equals 360. And distance from center plus equals distance step. And all we do is like, we just do fmath do like the sine of our angle multiplied by the distance from center, and we do the same thing with cosine. And then if we collide, then we continue. So if we don't collide, then we just call internal set position to test position. Let me break out of the loop. And then if we didn't find a place, then we just log it out. Unable to find location to smartly place our object. Oh, so we actually want to do this. So we'll just print out which locations we're actually testing. We'll see how that works. So nothing too crazy. We're we're basically just rotating around and putting ourselves out by half our height and seeing if we fit. And it's a pretty stupid smart placement function, but we don't need it to be too intelligent. We're just throw it somewhere around there. Because we shouldn't be... This is really just a try to find a decent spot thing. It's not trying to be absolutely perfect. We shouldn't be putting stuff into the world where things already are anyway. This is just to prevent some basic edge cases of like you try to spawn a dude and you spawn him inside of somebody else and just screws everything up. Alright, see you later, Plankton. Cool. Well, I might still be online when you get back. We'll see. Anyway. Because it's been, what, 9 hours since we started working on stuff today, so slowing down a bit. I might be on for a little while longer, but pretty much on the flying stuff, which shouldn't be too long to actually implement properly. So it looks like that smart spawn stuff is at least putting us basically where we should be. So let's put ourselves like in the ground. See what happens. And it did not put us in the ground proper. It put us in the ground, which it should not have. So let's take a look here. So we'll see. So this position is this one. Let's see, did we collide? Yeah, we collided. Then we tried to place ourselves in this test position. So exactly it was testing all these positions. Yeah, it tested all like 100 places. Like we were unable to find location to smartly place object. Look like maybe they're not working in radians. I mean, maybe they're actually working in degrees. Because I'm getting the same position for absolutely everything. The sign of C is that, and S is this? What? Our height was 0. Wait, what? So that's probably what was going on there, is we're just getting the wrong numbers. So our height is 48, which is correct. Our angle is increasing properly. Sine and cosine look actually correct. And we should be testing different positions here. And we found a good place to go. Alright, it looks like that actually worked. And this is our flying movement right now. Don't move if we're flying. So, okay, that's exactly what should be happening. So, we should probably delete our object if we can't spawn it. So what we're gonna leave that up to something later, I believe. Okay, so we at least got the smart spawning stuff in there, so we'll try to place ourselves outside of something. So we need a flying object physics. So what exactly do we want our flying object? So if we're flying, how are we in the hell gonna move? Well, let's take a look. Let's write down some stuff for flying physics.